Imagine checking the weather on a planet almost 690 light-years away, not just guessing its temperature, not just detecting gases in its atmosphere, but actually seeing that one side of the planet is cloudy, while the other side is almost clear. That is what the James Webb Space Telescope has now done. On a giant exoplanet called WASP 94AB, scientists found clouds that seem to appear in the morning and vanish by evening. And these are not normal clouds. They may be made of minerals, almost like sand. If Earth's weather forecast says cloudy morning, clear evening, that sounds normal. But on WASP 94AB, the clouds may be made of magnesium silicate, minerals that can form at extreme temperatures. In simple words, the planet may have clouds made from rocky material. On the cooler morning side, those clouds can form. Then powerful winds carry them toward the hotter day side. As the atmosphere heats up, the clouds disappear. So the weather forecast might sound like this: cloudy with sand in the morning, clear skies by sunset, extreme heat all day. That is why this story is so visually strong. It is not just scientists found a gas. It is a planet with a daily weather pattern. How can Webb see weather so far away? The planet is too far away to photograph like a normal planet. So how can Webb know anything about its clouds? The answer is transit spectroscopy. When the planet passes in front of its star, a tiny amount of starlight filters through the planet's atmosphere. Different molecules and particles absorb different colors of light. So Webb does not see the clouds like a camera sees clouds on Earth. Instead, it reads the atmosphere through light. It is like seeing a fingerprint. If the morning side and evening side absorb light differently, scientists can infer that the two regions have different conditions. That is how a planet 690 light-years away can become a weather map. This matters because for a long time, exoplanets were mostly dots in data. Scientists could tell that a planet existed. They could estimate its size. They could measure its orbit. Sometimes they could guess its temperature. But JWST changed the game. It can study atmospheres in far more detail. Earlier, JWST observations of WASP-39b revealed molecules such as water, carbon dioxide, carbon monoxide, and sulfur dioxide, showing that Webb could detect complex chemistry in an exoplanet's atmosphere. Those studies helped prove that JWST was not only a telescope for beautiful space images, it could become a chemistry lab for alien worlds. Now, with WASP-94AB, the story moves from chemistry to weather. The references from Rustam Kulov, Alderson, Ara, Tsai, and Feinstein are important because they were part of the early JWST exoplanet atmosphere work. Those studies focused on WASP-39b, another hot gas giant. JWST detected carbon dioxide, water, carbon monoxide, and sulfur dioxide. And researchers also studied clouds, photochemistry, and atmospheric structure. That was one of the first major moments when scientists saw how powerful Webb could be for exoplanet atmospheres. But there is a key difference. WASP-39b helps show us what alien atmospheres are made of. WASP-94 AB is helping show us how alien atmospheres behave. That is a big step, because an atmosphere is not just a list of gases. It moves, it heats, it cools, it forms clouds. It changes from one side of the planet to the other. That is weather. Hot Jupiters are some of the strangest planets we know. They are gas giants like Jupiter, but they orbit much closer to their stars than Mercury orbits the Sun. That makes them incredibly hot. Many are tidally locked, which means one side is constantly blasted by starlight, while the other side faces space. This creates extreme temperature differences, and extreme temperature differences create powerful winds. On planets like this, winds can move gases, heat, and clouds around the entire globe. So when JWST sees one side cloudy and another side clear, it gives scientists clues about how the atmosphere circulates. It is not just pretty, it is physics. On Earth, clouds are usually made of water droplets or ice crystals. But on very hot exoplanets, different materials can condense. Instead of water clouds, you can get mineral clouds. Silicates are the minerals that make up a lot of rocks. At extreme temperatures, these materials can exist as vapor. Then, in cooler regions, they can condense into tiny particles. So yes, some exoplanets may have clouds that are closer to rock dust than water. That is why scientists sometimes describe them as sandy or silicate clouds. It sounds like science fiction, but it is chemistry under extreme conditions. This does not mean JWST has found life. It does not mean this planet is habitable. WASP 94AB is a giant, extremely hot gas planet, not an Earth-like world. The temperatures are far beyond anything humans could survive. The real discovery is not about life. It is about the ability to study weather on alien planets. That matters because the same techniques can be used on many other worlds. In the future, scientists hope to study smaller and cooler planets, including rocky planets with more complex atmospheres. Understanding hot Jupiters is part of learning how planetary atmospheres work in general. For most of human history, planets outside our solar system were invisible. Then we learned how to detect them. Then we learned how to measure their size and mass. Then we learned how to detect gases in their atmospheres. Now we are starting to see weather. That is a huge shift, because weather means motion. Weather means change. Weather means the planet is not just an object. It is a world. A strange, hostile, impossible world, but still a world with patterns, cycles, and structure. James Webb is turning distant planets from dots into places. So the next time you hear about an exoplanet 690 light-years away, remember this. Scientists are not just asking whether it exists, they are asking what its sky is like. Is it cloudy? Is it clear? What are the clouds made of? Where do the winds go? What happens at sunrise and sunset? And on WASP 94AB, the answer may be one of the strangest weather forecasts ever made. Clouds of sand in the morning, clear skies by evening, and a world so hot that even its clouds cannot survive the day.